let's talk about the oxygen sensor heaters. Now, these universal oxygen sensors need a lot of heat to work normally. In fact, these sensors require a tip temperature over twice as hot as the narrowband sensor. So the heater circuitry is part of a very important diagnostic process for universal oxygen sensor heaters. You cannot condemn an oxygen sensor if the heater circuitry isn't working correctly. 12 volts is going to be pulsed to the sensor's heater, and the on time of that pulse is going to vary as the computer calculates what is needed to keep the temperature in the proper working range. Here we see a broken down oxygen sensor, and we can see that the voltage to that is pulsed. Whether it's a low side driver and or a high side driver, it doesn't matter. The heater circuitry can be tested with a voltmeter if you want to do it that way. Remember that a DVOM is only going to average the measured value, and that's why when a manufacturer supplies a specification for the heater, a voltage, it usually just simply states varies. As an example, the 12 volt value is going to appear as anything different depending on the duty cycle. It's not going to be 12 volts. It can be tricky to find these oxygen sensor heater wires, but use a vehicle specific schematic to do so. When the 12 volts is being turned on and turned off or pulsed, you're not going to see that B+. You'll see an average or a lower voltage than that B+. But don't panic. You have to understand your voltmeter is averaging what it's seeing, and the computer is turning the 12 volts on and off at a rate we don't understand or know the value of. So we're going to see something different. For example, an example only, we could see 6 or 8 volts or 100% depending on the duty cycle. Now this is because the meter is trying to give you the average over a period of time. It doesn't mean that the sensor itself isn't getting B+. When we look at the schematic, it's very difficult to see, does this oxygen sensor heater have a low or a high side driver? You can make a measurement to figure that out. Put your voltmeter on one end, and if you see the frequency value here, this is a low side control, and if you see it over here, then it's a high side driver or high side control. Use mode 6. Now that'll give you better test results than going down there using a voltmeter. The computer is going to perform monitors or tests, and they're going to do it on a continuous basis. Many of these tests that the computer performs, many of these monitors, we can't do ourselves. So mode 6 data is going to be the results of a monitor that the computer has run, and it's going to be a lot easier to do just to look at the scan data. The retests are not going to be live. In fact, you have to pay attention to the readiness screen. Example, at the top right we see oxygen sensor monitoring and the oxygen sensor heater monitor, and you can see they're not complete. The computer did not run the test for the oxygen sensor heater. So at this point we have to drive the vehicle until these monitors run and complete, because when they're incomplete or not complete, that means the data in mode 6 is not accurate, it's not up to date, and it should not be used. Here we see a screen of mode 6 data, and let's blow it up so we can see it up here in the right hand corner, and we can see the heater circuitry has been tested, and the computer ran this test when all the conditions were ideal, and the computer knew exactly what the duty cycle for the heater current was. Now we can see a min, a max, and a measured value above the red arrow, and we can see this for each of the oxygen sensors, whether they're a fuel control sensor or catalyst sensor. Let the computer tell you about the universal oxygen sensor heaters test. Let it give you the results. You can of course do it with a voltmeter, but it's sort of ambiguous. You never really know exactly what it should be.